Okay, let's see. Can you see it now? All right. So, working alone, John can paint a fence in 6 hours. So there's an individual, T1 equals 6. Deshaun can paint the same fence in 7 hours. So there's my other individual, T2, right? 7 hours. So the total time, how long would it take them? So that's my total time if they work together. So we're supposed to find that. Okay, let's plug it all into our formula and solve for T. So I have 1 over T equals 1 over T1, and my T1 is 6, plus 1 over T2, which is 7. All right, so now I got a rational equation to solve. And for word problems, since we're not dealing with such difficult denominators, let's just use a common multiple. Okay? We're not even going to worry about the lowest common because we have calculators, right? So common multiple or common denominator, we're just going to take our two numbers here and multiply them together. I got 42, and I have to include the t, right? So I'm going to distribute my common denominator or multiple, however you want to say it, to each fraction. I'm going to multiply to each fraction, right? Okay. So the first fraction, let's see, the t's cancel out. So I'm going to multiply my numerator by 42. My second fraction, let's see, the 6 goes into 42, well, 7 times. I'm just going to multiply it by the other fraction's denominator. But don't forget the t. And then this one, multiply it by the other denominator, 6. Don't forget the t. Takes care of this denominator. So I'm left with 42 equals 7t plus 6t. Solve for t. 42 equals 7t plus 6t is 13t. Divide both sides by 13. And t equals, anybody do it? What is it? 3.23. And go back and kind of just think about the answer for a sec. Let's see, individually they can do it in 6 hours and 7 hours. Together they can do it in 3.25 hours. Yeah, it kind of makes sense, right? Makes a lot of sense. So we're pretty sure that this is good. Okay, 32 again is another work problem. Working alone, Perry can pick 40 bushels of apples in 9 hours. So we have Perry, 9 hours. That's my individual, so it's going to be T1, 9 hours. One day, his friend Michaela helped him, and it only took 3.94 hours. Okay. Now, be careful here. It doesn't tell us how many hours Michaela put in, but it did tell us it took the total of 3.94. So this time I have to find Michaela's individual time, which is T2.
Hey, I thought the 3.94 was T.
It is. Both of them together took 3.94. So that's my total time.
Yeah, I thought the 9.
The 9 is just Perry.
Oh my god, I didn't see
Okay.
that.
9 hours was just Perry. Okay. The total took 3.94. So I got to find T2. So I have 1 over the total T, which is 3.94, equals my 1 over T1, which is 9, plus 1 over T2, and that's the one we want to try to find out. Now, if you want to put an X there, that's fine. Last hour I used actually T2, and it kind of got a little messy. Okay. So we'll call this our X. All right, my LCM, or actually, let's just find a common multiple, CM, or common denominator, right? We're just going to multiply the numbers together. Let me get my handy dandy calculator. So I got 3.94 times 9 gives me 35.46, and then I need an X, right? Okay, let's go ahead and start solving this. Let's see. This numerator is going to be multiplied by 9, right? Because we multiplied them together. So this is going to be multiplied by 9 and the x. So we're good with that one. This fraction, we're going to multiply by the numerator by the 3.94. And don't forget the x. Takes care of that denominator. This one, we're going to cancel out the x's, right? And I'm left with 35.46. So my new equation here without fractions, I have 9x equals 3.94x plus 35.46. Now all I have to do is solve for x, right? So I'm going to subtract 3.94x from both sides. Again, I'm going to use my handy dandy calculator. See, 9 minus 3.94 gives me 5.06 x, these cancel to 0, equals 35.46. Divide both sides by the coefficient, 5.06. So x is going to equal, so 35.46 divided by 5.06, and we get 7. So about 7 hours, right? Go back, do a quick check. Yeah, he could do it in 9. Yeah, 7 hours seems reasonable. So that's how you do the working problems. You got to use that formula. Got to use this. 33 and 34 are distance times distance equals rate times time. So it helps to make a chart. Let's see. I have distance equals rate times time. Okay, ready? Mulford traveled down to the town hall and back. On the trip there, so we got the trip there, he traveled 75 miles per hour. It's kind of like my trip to work every morning, 75 miles per hour. And on the return trip, so we have a return trip, he went 60 miles per hour. How long did the trip there? So let's see. How long? So we're there. How long? So we're looking for time, right? How long did the trip there take if the return trip, so the return trip took 5 hours? All right. So this actually is, these distance problems are actually kind of easy because the distance is going to equal 75 times x, and the distance on the return, 60 times 5, 300. And we know the distances are equal because it's to the same spot, right? There and then back. So we know that these are equal. 75 equals 300. Divide by 75. And we have 4, right? So it took 4 hours. And again, makes sense because it should be a little less than 5 because it went faster. All right, 34. Again, it's another distance problem. We're going to set up our chart. Okay, a diesel train left the station and traveled east at an average speed of 30 kilometers per hour. So I have the diesel train, and it traveled 30 kilometers per hour. There's my speed, my rate. Sometime later, a freight train, there's a freight, in the same direction, but an average speed of 54. So that's given 54. After traveling for 5 hours, the freight train, so the freight train traveled 5 hours, caught up with the diesel. How long did the diesel train travel? So, diesel train, how long is what they're asking before the freight train caught up? Okay. So, the distance that the diesel train went was 30x, and the distance for the freight train, let's see, 0 to 270. Well, this one's easy. 9, right? 30x equals 270. Divide by 30. So x equals 9 hours. And again, makes sense. It should be smaller, or it should take longer because he went a lot slower. Okay. And then the last type of problem, let's say we had working problems, distance problems. These are mixture problems, right? Mixture problems, you're going to have to set up some charts. And usually we have 3 rows instead of 2. So I'm going to make a chart here. And I'm going to make 3 rows. Okay. Let's see, we got 12 pounds. So this one's going to be pounds. And the percent I like to put first. I need percents, pounds. And again, this is going to be I just call it the total column because we're multiplying these two together to equal this. Okay. 12 pounds of mixed nuts. So we have mixed nuts.
Actually, there's two types of mixed nuts.
Yeah. So,
So I guess mixed one, mixed two.
yeah, mixed one and mixed two sounds good. Okay, so mixed one, we have 12 pounds is given. 25% is given, so 0.25, right? With 8 pounds of another kind, so here's given 8 that contain 35, so 0.35. What percent of the new mixture, so they want us to find the percent of the new, so we'll call it new. What percent of the new mixture is peanuts? Okay, so let's fill in the other blank boxes, okay? Let's see, I'm going to multiply these two together. 0.25 times 12. 3. 0.35 times 8. 2.8. Okay, so here I've got 20. And 3 plus 2.8 is 5.8, right? Okay, so 20x equals 5.8. So divide both sides by 20. And my x is going to equal
Point two.
okay, 0.29. X equals 0.29 or
Point two nine.
29%, right? Move the decimal over, we get a percentage. Does it make sense? Well, yeah. Our mixture should be between 25 and 35%, and it does. And the last mixture problem, it's the same thing, really. I don't even know what they're asking. Sometimes they ask for pounds or, we got to figure out what they're asking.
No, it seems like fluid.
So they're looking for the weight, right? So we have ounces, percent, and then the total. Okay, we have 30% of acid. So Here's acid is 30% or 0.30 must be mixed with um,
X amount.
12 ounces of water, right? So we got 12 ounces of water. And what's the percent of acid in water? Zero. Good. And we need to make a 12% solution. So solution is 12%. Okay, the only thing we don't know is the ounces of acid, right? Okay, let's fill in the other boxes. Again, we're multiplying in equals 0.30x, 0. Well, this one's going to be easy. Okay, the amount of ounces I have, we got to add these, right? X plus 12. Multiply these two together. 0.12 times x plus 12. So we know that 0.12,
Wait, would that be like 30.30x with the zero?
yes. Yeah, we could put, I was going to put it after, but that's okay.
I'm sorry.
0.12 x plus 12 equals 0.30x.
How did we get that?
I suppose I should have put that first and then that. Okay. All right, distribute 0.12 times x, 0.12x, 0.12 times 12. Well, 12 times 12 is 144, right? And then I got to go two decimal places, so 1.44 equals 0.30x.
I'm still confused how you got x plus one.
Well, I need the total ounces. This one, we had the total ounces, but they were giving us the pounds, right? So 12 plus 8 was 20 pounds. Here, they didn't give us the ounces of acid.
Oh.
Okay, so I'm going to do x plus 12.
I'm sorry.
Okay. All right. Let's see. I got to solve for x, right? So minus 0.12x from both sides. I'm going to bring it back up here. So I have 1.44 equals, let's see, 0.30 minus 0.12 is 18x. 0.18x. Then I have to divide both sides by 0.18. What is it? 8 ounces? Yep. And it makes sense. Okay. We need just a little bit less than 12 because it has 30% solution. So, how do you feel about word problems?
Are we doing the same thing then?
Remember, three types of word problems, right? Word problems, we got to use this. Distance problems, you got to use the distance equals rate times time. The mixture problems, you're setting up charts with ounces times the weight equals the total. Three type of word problems. It's going to fit one of these. So, um, on page 45, 46, and 47, you've got page 45 is all work problems. Page 46 are distance problems. And then page 47, you have mixture problems. So I'm certainly not going to require you guys to do all the problems. Okay? 16 problems, that's a lot. Even half of them is quite a bit. So here's what I suggest you do. Out of the pages, pick one, do it. If you think you need more help, or if you match it up, I'll have the answer keys on Google Classroom. If you're not getting it, do another problem. You have 6 problems to do, but keep trying until you get it right and you understand it for each concept, right? Working, distance, and mixture. And again, I'll put those answer keys in Google Classroom. I'll leave it up to you how many you need to do.
So we do two.
Okay. If you choose to do 2 of each, that's fine.
I'm just gonna tie the distance for everything. What the work.
Yep. Any questions, guys?